Okay, students. In the last video, you learnt about the singleton set. So, what was a singleton set? The core value should be only one core value. If you have multiple core values, it will not come under your singleton set. Okay. Now, what is meant by alpha cut and strong alpha cut? So, better I'll explain with one example. We'll see here. Okay. Yeah. Suppose if I say that, I'll take one example directly. Now, A equal to 1 comma 0.2. Okay. 1 second. Okay. A equal to 1 comma 0.2. Okay. This is my first element. 2 comma 0.3. I'll take one more element. 3 comma 0.4. This is my set with the membership values. Now what I'll say here is I'll tell that alpha equal to 3. Sorry, 0.3. Okay. Now what is strong alpha? Okay. So you have to check all the membership values whose values are greater than 0.3. This is called as strong alpha cut. Okay. Strong alpha cut. If it is greater than or equal to 0.3, this is only alpha cut. Okay. So if you see the example, what you understood here, which are the values under strong alpha cut? Only 0.4. Only 0.4 will be the strong. If I take this one, I'll get 0.3 and 0.4. So what will be the solution? I'll just write here. 1 second. Now if I take strong, what will be the solution of this particular strong alpha cut? It should be greater than, only greater than. So I'll get only 0.4. If I take normal alpha cut, what I'll get? I'll get 0.3, comma 0.4. I hope it is clear. So if you take strong alpha, it should be only greater than. You can take any condition, not an issue. You can take less than, greater than, you can take the range. It may be 0 also, not a problem. So if you see the equation, A alpha equal to x mu A of x greater than or equal to alpha. Here it is only greater than. So this is called as alpha cut and strong alpha cut. Now next one is convexity. So what is meant by convexity? Okay, here we have to understand some values. So what the values we required? Here we have the lambda. So how we have mentioned in the alpha, here you have the lambda. So what is the formula for this? So mu A of lambda of x1, you have to take the two elements. First and second element. First element will be x1, second element will be x2. So lambda we will substitute. Lambda of x1 plus 1 minus lambda of x2 should be greater than or equal to minimum mu A of x1, comma mu A of x2. Okay. So we'll do one thing. We'll try with one example. Then it will be easy for you. Okay. So we'll take one example and we'll solve it. 1 second. So we'll go to our this one. Yeah. Okay. So what was the formula? Mu A of lambda x1 plus this is not why it is not working. 1 second now. Okay, I'm writing here mu A of lambda x1 plus 1 minus lambda x1 should be, sorry, here it should be overall, it should be x2. Okay, very clearly. We should not confused. Okay, done. Mu a of, here it is lambda x1 plus 1 minus lambda x2. This is first part. Should be greater than or equal to minimum of mu a of x1 comma mu a of x2. So this is our equation. Now what we can do here is, we'll take one example. A equal to, I'll write here. So don't think that I'm only using always here. You wish you can use anything. I'm taking 1 comma 0.2. x2 is 2 comma 0.3. You can take any values, not an issue. And what is another element we require? Sorry, lambda. Lambda equal to, I'm taking 0.2. Now you just substitute in this equation. So mu a of, what is the formula here? Lambda. What is lambda? 0.2. What is x1? X1 is 1 into plus second one 1 minus 0.2, okay, into x2. So what is this? What you will get here? Mu a of, this is 0.2 plus 1 minus 0.2 is 0.8. So here I am getting 0.8. So what we have to check? Minimum of mu a of x1 comma x2. So just I am rubbing this part. And just this part I am rubbing. It will be easy for me. Now what I'll check here? I got here 0.8 should be greater than minimum of, what is your mu a of x1? Mu a of x1, it was 0.2 comma, second one it was 1 minus 0.2 into x2, okay, whatever, just take 0.3. So this is 0. Is greater than minimum of 0. This is minimum equal to 0.2. So obviously 0.8 is greater than 0.2. So this is convex. Okay, you can say that this particular set is under convexity. Done. So this, if you have multiple values, you have to calculate for different elements. Okay. Next, what is meant by bandwidth? So if you see this particular thing, always remember that the bandwidth is between two unique crossover points. Remember this, what is crossover point? Whose value is 0.5. Crossover means it should be 0.5. So if you have two 0.5s, that particular difference, okay, I'll show you the diagram, then it will be easy for you. 1 second. Okay. So if I draw the graph, this is here, somewhere here. If I take here 0.5, I'll take 1. 1 point was here. Okay, 0.5, 1 point was here. I'll take this one x1 and I'll take this x2. So what is your bandwidth equal to? X2 minus x1. Here if you have here x0 or here you have x3, we don't convert, we don't care because the two crossover points should be equal to 0.5. That is crossover. So I think it is got it. So bandwidth is difference between two crossover points. Now coming to the next one, symmetry. So what is meant by symmetry? Same thing. It is you are taking some point x. Okay. If you see the graph, at some point C, this equation have to be satisfied. What is that equation? Mu a of x plus c equal to mu a of x minus c. This c we have to calculate. So where both the values are same. So that particular value is called symmetric. Okay. Now, One more interesting thing for fuzzy set, we have different types of this one: open left, open right, closed. Okay, what is meant by open left? Open left in the sense, if you see this particular graph, this blue color one, we don't have the starting point, it is infinite. Okay, limit will be starting from infinite, x2. So here, if you see this one, mu of x equal to 1 and limit equal to mu a of x is from infinity to 0. So it is starting from infinity and ending with the 0. Got it? Now, what is meant by open right? Okay, here you'll have the starting point, but ending point will be infinite. So that is called as open right. Now, what is a closed? You will have both the limits. This is left limit, right limit will be there. So this is called as closed one. So if you see this one, see here, red color is closed. Starting it is 0, ending it is 0. Blue color, starting is infinite, ending is 0. Open right, starting is 0, ending is infinite. So these are the different types of fuzzy sets: open left, open right, and closed. Okay, so this is done. So what we have seen so many things about what is meant by bandwidth, the symmetry, convexity, what is meant by open, closed, all those things. So it will be very easy if you practice all these examples. Thank you.